Hello everyone, it's great to see you guys joining early. Stay tuned, we'll be starting shortly. I think Anudeep is here with us. Hi Anudeep.
Hello, good evening.
Yeah, good evening, you're audible.
Thank you.
Yeah. We'll start in 5 to 10 minutes. Let everyone join.
Yeah, sure.
Yeah. Hi, Prince. Good evening. Hi Ashbir. Hello Christian. Hi, Benjamin. Hello, Emmanuel. A lot of people have joined. Okay, hello everyone. Welcome to another session of DataHour series. We will start in 5 minutes. Until then, let's get to know each other. We have put up a poll which contains two questions. One is about your location and one is about your experience level. Please kindly answer the questions in the poll. Uh, I hope everyone can see poll on your screen. Hello, Raj. Hello, Yash. We'll start in 5 minutes. I request everyone to answer the questions in the poll. Hello, Mohammed. Hello, Himanshu. It's great that most of the people have answered the questions. Guys, whoever has joined just now, please answer the questions in the poll. I think it's time to start the session now. Most of the people have joined. Hello and welcome everyone to another session in the DataHour series. We are thrilled to be here with you this evening for a session full of action-packed learning. I am Dheeraj, part of data science team at Analytics Vidhya, and I will be the moderator for the session. And guys, for those who have joined us for the first time, let me give a brief introduction to the DataHour sessions. The DataHour is a series of webinars conducted by Analytics Vidhya and led by top industry experts. It is a fun way to understand the concepts of data science from the leading players in the data tech domain. And as the name suggests, it's totally one hour dedicated to data. And guys, we are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. Now, on to our session today, which is Think Like a Data Scientist. Uh, Generally, today, computational power is a major challenge that every data scientist must overcome. And companies seek experts who can economically extract forecasts from the raw data. Data scientists need to treat the raw data correctly and extract the required features in order to make accurate predictions. And now domain knowledge plays an important role in feature engineering and carrying out analysis efficiently. And guys, I hope you are excited to attend this data with us. And one important note to everyone that before we kick things off, a quick recap of housekeeping items. And guys, don't worry, we are recording the session and we'll make the recording available in a few days on our YouTube channel. And guys, please feel free to use the Q&A section for asking any questions. Please make this webinar more interactive and we will do our best to answer them as the data progresses or towards the end. And also we will share a poll about the feedback of the session towards the end of the session. And please kindly fill up that poll also. Now, on to our speaker in this session of DataHour, we have Mr. Anudeep Sri with us. Anudeep is a graduate research assistant at University of Massachusetts. He has 6 years of experience using Azure Cloud Services, Big Data, and Artificial Intelligence to analyze data of any size and format to produce insights and predictions. And he also has 2 years of experience in mentoring fellow IT professionals in AI real-time case studies as part of his PGP program. And he also mentored 127 IT professionals in progressing their careers. He delivered 21 guest lectures on AI and cloud computing at various international platforms and universities. Now over to you, Nadeep. The virtual stage is all yours.
Thank you so much, Dheeraj. Hello, everyone.
Yeah, you can share your screen now.
Yep. Thank you.
Now, please try once again.
Yes. Yeah.
Yeah, sure.
I hope my screen is visible.
Yes, visible.
So, hello, everyone. Thank you, Dheeraj, for giving me a quick introduction. I will directly jump into the topic. So, today I want to talk about how to think like a data scientist. All of us know most of the things with respect to Python, with respect to the machine learning models, with respect to how to uh, understand the predictions. But most of us miss out on the major concern of thinking like a data scientist for each problem. Whenever we as a data scientist are given an objective, all of us will be lost in trying to get the insights from the data that is given to us. So what exactly we need to think so as to extract the right insights is what I'm going to talk about in this session. And I would like to make sure that all of us understand, as most of us are from different backgrounds and different work experience levels. So I would take things a little slow. I would request everyone to bear with that. And I would not get into explaining little details about what is predictions, what is data, such kind of basic aspects I'm not going to get into because our time is limited. So I would be explaining you on how to think like a data scientist with a practical example. I am going to take up a Kaggle notebook and I'm going to explain the entire notebook to you on how the particular person had thought through to derive the insights. So let's go ahead and understand what exactly are we trying to do in a data science field. Let's say we have joined a company and we are given an objective, which is nothing but a business initiative. As in, let's say, for example, a company wants to increase its profits and it says the data scientist that, I have an historical data. Please analyze this and let me know how can I improve my profits. This can be a simplest objective that one can have. And now, what should a data scientist do is to understand what exactly are the features or what exactly are the constraints that are affecting the profits of a company. So that is what we do in step number 2, identifying the stakeholders. Next, we from these stakeholders, some of them might affect the profit largely and some of them might have a little impact on the profits. So we try to make sure that based on the understanding that we have on the domain that the business is into. So different businesses are into different fields, am I right? Some of them are into fisheries, some of them are into TV business, some of them are into entertainment. So there are vast fields that businesses can happen. So we need to identify and prioritize the use case to which we are applying this particular thought process. And we need to get to know all the data sources that are required for us to do an analysis. So let's say, for example, if I'm in an entertainment business and if I want to understand whether my current product can be marketed well or will it have proper revenue, for that what we would do is to find some products which are similar to my new product and understand whether the other products which are similar perform well or not. Such kind of data sources we try to find out, and we try to join them and try to extract the scores that where we understand whether we are having a huge impact with this data or not on the objective. And finally, we try to recommend the predictions. Based on the predictions, we try to extract the information so as to deliver it to the business, saying that, by doing so and so step, you can achieve profits. For example, by improving the product, by improving the definition of the video. Let's say video is the delivery of a product. By improving the quality of the video, you can get more profit. It can be as simple as that. But how do you achieve to this conclusion is what you try to apply machine learning models. For example, as simple as k-mean, such kind of algorithms, as simple as that. And finally, achieving the results. Let's dive in and understand in a more broader perspective with respect to data science. Let's say we have a data set given to us and we know the objective, and we try to get the data. We try to get the data in such a way that it tries to give us the insights on what exactly the data is trying to convey. So there are different data processing and wrangling methodologies wherein we try to do exploratory data analysis and understand the data first. And then from that, we understand our features and try to extract them and do certain feature engineering aspects so as to make sure that the kind of data that we are sending into the model makes sense to the model. Finally, we try to do feature selection, as I said, not always do we have features that impact a lot towards the target variable. So we try to select the features that would affect our target variable a lot. This can be achieved using a technique which I would be talking a little later. So once I am done with treating the data and doing the feature selection, and I would proceed to applying a machine learning algorithm on top of it. So will I be done by applying a machine learning model? Not really. We don't know how it would perform with the data that is given to us. Once we evaluate the model, we try to tune it. We try to use some optimizers. We try to use ensemble techniques, etc., so as to make sure that the model is performing well. And not always we might end up in having a good accuracy, which is why we go back to this step to make sure that we are doing it right. So this is our primary area of interest so as to increase the accuracy. And here is where we need a lot of domain knowledge so as to improve the way we are sending the data into the model. Once we are satisfied with the model evaluation and the kind of results that we are getting, that is when we go ahead and do the deployment. And are we done with the deployment? Not really. Again, we have to understand the kind of data that is being generated and being sent into the model. And with that, we keep monitoring the model and see how it is performing. Sometimes tuning might be needed. Sometimes in certain domains, you might have to intervene and change the features periodically. There are so many domains where it keeps changing. For example, stock exchanges, for example, oil prices. So in such areas where market is affecting your product, there is where you will have to keep monitoring your model and try to keep changing the features and doing a lot of feature engineering. What is our area interest right now is this data preparation activity, and let's dive into it. Now, using this particular case study, I'm going to show you how domain knowledge is quite important and how advanced feature engineering would help us in getting a good accuracy despite having a naive data. I hope we all know the Titanic. This Titanic boat had sunk in the sea, and we are trying to now predict the survival rate at which the passengers can survive. So this picture is trying to show you what are the different kinds of aspects that are affecting our target variable, which is survival. And we need to quickly understand and learn the aspects that are related to this Titanic so as to do the prediction. Like many of us know Python, many of us know all that I'm speaking, model evaluation and all that. But what makes a huge difference is feature engineering. What is that we do in a general way? How do we apply the data on top of this model? Is that first we import the necessary libraries, read the data from the source, and we do the exploratory data analysis where we try to understand the kind of features that we already have. What if we have missing values in this given data set? We should have to treat them. Next, we understand the correlations in the given data set. Correlation as in how well the feature that is given to us is affecting the target. And once we have treated this missing values and we have the correlation done, we try to do feature engineering and something called feature transformation. And finally, send in these selected features and engineered features into the model so that we get the metrics. Once we are satisfied with the metrics, we get we take up the predictions and then try to infer what it is trying to convey. Coming to feature engineering, what exactly are we trying to do when I say treating the missing value is what imputation technique is all about. Imputation means that we are trying to substitute a value instead of a missing value. There are so many techniques to do imputation. There is mean imputation, there is median imputation. Here I am showing you what is a mean imputation. So mean imputation, what it does is that it tries to calculate the mean or a median from the non-missing values in a particular column. And then what we do is that we replace this particular value with all the missing values so that all the missing values or the blanks that are there in the data set are replaced by a numerical value. Why are we doing this is because once we have all the numerical values in a particular column, we can promote it as a feature. Remember, your machine learning model is a mathematical model, which takes in only numerical values. So for that purpose, we try to avoid blanks. What are the pros of doing this kind of mean imputation for the missing values? It's very easy and fast, and it works well with the small data sets. But this doesn't go well when the data set is huge, and it will give poor results on encoded categorical features. So we don't use this on a categorical feature, isn't it? So when there are only zeros and one, we can't go ahead and impute the value 0.5, which is the mean of 0 and 1, to the missing values, because it doesn't make sense. We are trying to say that it is either 0 category or category 1. So if we impute 0.5, the model will give you wrong results. I mean, you would get all false positives. So this does not lead us to good accuracy, and it doesn't account for the uncertainty. I mean, this becomes a lot of this kind of imputation. What it does is that it gives us lots of uncertainty in predictions, which will not really help us. There's another way of imputation which is called most frequent. As in, sometimes let's take the example of categorical variables, wherein you have zeros and ones. So I would go for something which is more frequent when there's a missing value. Let's say there are more ones. I would first impute the values uh, of one in place of missing value so that I can get the accuracy well. Now, what are the cons of doing this for a categorical value is there's a high chance that we are introducing bias to the model. So again, we will have to do certain techniques so as to remove the bias, and it doesn't factor so much regarding the correlations of the features. So these are the cons that we have in this kind of imputation. There is another way of imputing values using KNN. So I hope we all know what is KNN. It is nothing but the k-nearest neighbors algorithm. So it uses something called feature similarity to predict the values of the missing values in a particular feature as a new data points. So let's see what are all the pros and cons that are involved in this kind of imputation. It can be much accurate than the mean, median, or most frequent imputation methods. But what is our main concern here is the computation effort. Companies are not ready to spend so much money on computations because it would cost highly. So that is why we don't go for this unless it's very important for us to do it. So this KNN is quite sensitive to the outliers. When your data has so much of outliers, you wouldn't be able to apply this technique. So these are the things that we keep in mind. One analogy I can take with respect to imputation technique is that, see, for all the machine learning models, we all know certain cons, certain pros for each model, by which we try to decide based on our objective to apply a particular model. Isn't it the same thought process we try to apply for imputation technique also? Based on the data that is given to us, we try to analyze and understand what exactly the data wants, and based on that, we use the imputation technique. Are we limited to only these two kinds of techniques? No, there are certain more techniques that you can go ahead and understand. Just by Googling different imputation techniques, you would get a lot of info on that. This is one area where you can dive through so that I'm sure you see these days there's a lot of missing data in the data sets. So this would help you. I'm going further. There's something called a binning technique, which is quite useful when we were given certain words kind of a data. Let me give an example. Let's say we were given a range, for example, BMI. We have a column called BMI, body mass index, where, we have a range as the value given in a column. To such kind of stuff, what we can do is that we can do something called binning, where we can convert this numerical data into something called low, mid, and high. As in, we can convert this again into categorical, right? So this kind of technique can also be used with your data set so as to do certain feature engineering. So when do you apply this and how do you do this is what and where you would require a domain knowledge. So this is why I was stressing a lot on why domain knowledge is very important. Let's dive into the Kaggle notebook. So before I go, any quick questions?
Guys, if you have any questions, please ask.
I hope I'm clear in setting the context of why we need feature engineering and why the domain knowledge is very important.
Yeah. And Mr. Nandip, many of the people are asking about to share this PPT.
Yeah, I can share. I don't have any problem.
Yeah, sure. There are
Good
many
question. So, how do we make the data unbiased? Is there's a separate topic on this where you try to do something called balancing techniques. So that is a different topic. Please understand that we are limited to the data science framework kind of questions. I understand, when you don't know that topic, you would have questions, but I would say please go ahead and Google, because there's a lot of info on these topics where you can spend days together to understand what other techniques can be used. Somebody is asking about SVM imputing technique. SVM imputing technique is nothing but applying this particular SVM algorithm on top of the data so as to predict these missing values. Okay, I understand your questions. So most of them would be definitely clarified once we go through this Kaggle notebook. Let me bring up this Kaggle notebook to you guys. Yeah. Just give me a moment. I hope my screen is visible with the Kaggle notebook.
Yes, yes.
Yeah, thank you. So why I have taken this example of Titanic is because it is easy for every one of us to uniformly understand something which we all know. And now our domain is Titanic ship. This is our domain. I would request everyone to clear all your questions right now. You would be answered for sure. So please come along with me as we dive through this kind of thought process on how to think like a data scientist. Uh, let's understand that, when there's a data set that is given to us, the first thing that we try to do is to exploratory data analysis. As the name suggests, we try to go ahead and explore the data. Once we have the idea on what exactly are the features, we do something called feature engineering. Once we are done with the feature engineering, we finally go ahead and apply a model onto these features, which are engineered and sometimes which are selected from the dataset, right? So this kernel is top 2%, which has 83.7 percent score on the public leaderboard in Kaggle. Let us go through. It takes nice time to understand this one. As I said, the first steps first, we import the necessary data sets. Sorry, we import the necessary libraries and go ahead and take the data sets. The given data sets, you can, I hope everyone is well versed with Kaggle. You can get the data set here. They have the CSV file. And here the author had tried to give us the data. It says that the training set has 891 rows and test set has 418 rows, which is quite a small data set when compared to real-time scenarios. Training set have 12 features and test set have 11 features. I hope everyone knows why this is, because training set will have the target column included as a feature, and test set will not have the target column because we wanted to test the model. And one extra feature that is nothing but survived, which is what we are trying to predict. This is our target variable. I hope we are all set with what the data is. Here, the author is trying to establish the number of training examples, test examples, the same thing that it was provided here. So here, he's trying to take the data into data frames, and and observe that there are survived column in the training set and we don't have survived column in the test set. Now we dive into this particular index that we have. What are all these columns that are given to us? Let's understand. First one is passenger ID. This is the unique ID, and survived is nothing but the target variable for us. When it is 1, it means that the passenger has survived. When it is 0, it means that the passenger did not survive. P class is nothing but the passenger class. Again, it is categorical. If it is 1, it is upper class, 2 middle class, and 3 lower class. Name, sex, age are, self-explanatory. Sex is nothing but your gender. Age is nothing but the number of years, and name, self-explanatory. There's a column called SIB and SP, which is nothing but siblings and spouse. The total number of the passengers is given in this column. And this is parents and children. This is again a number. And ticket number is given to us. Fare is nothing but the cost of the ticket. Cabin is the cabin number given to the passenger. And embarked is nothing but where the passenger has embarked onto the ship, right? Which it has 3 categories, that is C, Q, S. These are the places where the passenger have boarded the ship. So these are our columns. By looking at our columns, by now you might be having a thought that we will have to remember passenger ID because it is uniquely distinguishing all the rows, isn't it? So hold on to that. We'll go ahead and see how the author had treated this. So once you see the head of the data, it looks like this. As you can see, the name is in the format of last name, comma, salutation with the first name. And you can see there are a lot of missing values in the form of NaN. Now we have an issue of missing values. And here is where we try to use something called mean imputation. Let's see how the author has treated. So first we try to display all the missing columns. We have come to a conclusion that the training set has missing values in age, cabin, and embarked columns, and test set has missing values in age, cabin, and fare columns. So let's see how much amount of rows are missing in each column. As you can see in the training set, in each column there are 177 missing rows, and in cabin there are high number of missing rows, and embarked column there will be high there are only 2 missing values. Generally, for the small data set, we can't let go of 687 columns, isn't it? 687 rows, isn't it? Because we only have 800 rows, and out of them, if we remove all the missing values, there's no point in applying a machine learning model. So we will have to treat these missing values so that we can use the entire data set on the model. So age column, there are 86 missing values in the test set, and in the cabin, there are 327. Let's see how each column is treated for the missing values. For age column, the author had done a beautiful job of segregating the people using P class, which is nothing but the passenger class. He had grouped them, and then he understood that there's a high correlation with age, and also the target column survived. So what he did is he felt that it is more logical to group ages by passenger class instead of other features. So how do you arrive at such a thought is just by understanding the correlation coefficients. So first, what would you do? You try to understand the correlations and see with what feature that this particular feature is being affected more, which is nothing but 0.408. Just think about it in a simple way. When our parents are going to a trip in a train, what would we do? Even though whether we afford or not, we try to book it in a third class AC, because for a long journey, for our parents to feel comfortable, we'll try to do that. Similarly, that is the reason why your passenger class is more correlated with age. So, and then he also thought that in order to be more accurate, the gender feature is used as to second level of group by. So first he's doing by class, passenger class, and then he had done using the gender, so that he found that median age of passenger class 1 females is 36, males is 42, which means he's trying to convey that there are lot of differences in the median values when it comes when the data is grouped by passenger class and females and males. So this is how he had come to a conclusion, and these are the values that are going to be imputed in the missing columns. Am I clear? Am I going fast, or you are good with this? Okay, I see it's good. Fair enough. And I quickly want to draw one more analogy, guys, just to make sure that you are understanding it. See, the whole thought process is something like this. Most of us must be interested in crime thrillers. Let me explain with that analogy. So, the crime is our data, and our criminal is the insight. We need to find it, and we are the police. So, everything that is given to us, which is nothing but the crime scene, we need to get all the clues that are with the crime scene so as to catch the criminal, isn't it? Likewise, everything that is given to us in the form of data need to be investigated, need to be thought through so as to arrive at proper insights, people. Because your accuracy will be saying something, but it does not make sense at the end. Even though if you have an accuracy of 90%, and even though you draw insights mathematically, but when it is coming onto the paper, as in when you are translating it to the business, it might be of no use. Let's say we are telling a business that, do certain steps to increase the profit. And eventually when they do it and it did not raise the profit, which means we are wrong as a data scientist, isn't it? So why is that happening is because we as a data scientist is not able to utilize everything that is given to us. That is why you can see in this particular notebook that the author is trying to get each and every information that he can get by Googling or by understanding the domain knowledge, and he's trying to implement that. Okay. There's also a lot of common sense that is applied into this. I hope you would understand this as we go forward. Now, this is how the age is treated. Next, we have something called embarked. Now, embarked, as I told you, it is the place name, and there are only 2 missing values in the whole data set. But did the author leave that? No, he did not delete those rows. He tried to get the information. So what he did is that he tried to understand what are the what are the nulls that are there in this embarked column, and he tried to get the particular rows. Now, what he observed is that he observed the passenger class, he observed the gender, and he observed the siblings and spouse count. As you can see, they both look like females with 0 siblings and spouses, and they have the same ticket number, and they are into same cabin B28. So and passenger class, most importantly, is upper class. So that is what the author tried to summarize here. Necessarily mean that they embarked from that port. So for an upper class female passenger, it's mostly C. So they have he has assumed that it is C, but he Googled it with the name. So you can see the name, right? He Googled the name, and he found out from this website that she is the person, and she had boarded with her maid. And you can see how C is being changed to S. Am I clear, guys? So even though C is the most frequent value for an upper class female passenger, these both missing values are to be actually replaced with S. So this is what author had done. He had filled it with S. Next, he went ahead to fare, which is nothing but the cost of the ticket, and he found out there's one row that has a missing value. So what he did was, based on the passenger class, he tried to understand how many parents and children and siblings and spouse will be, because your ticket is priced on based on the number of people who embarked onto the ship, isn't it? So that is the reason why we are grouping by parents and children and siblings and spouse, and the median fare is being filled into that missing value. Now we are going into something called cabin, in which there are so many missing values. So this is where the author had went ahead and got the information on how the cabins are distributed across the Titanic ship. So cabin feature is very big, a very tricky place to play with. So the large portion of the cabin features are missing, and cabin values are the decks in which cabins are located. So these decks are mainly separated for one passenger class, but some of them were used by multiple passenger classes. So this is the problem, right? It cannot be easily imputed based on the passenger class, because there are a mix of passenger classes in the decks that are there. So he had summarized his domain knowledge in this few in this few lines. So on let's understand this. On the board deck, there are 6 rooms labeled as TUWXYZ, but only T cabin is present in the dataset. And ABC decks were only for first class passengers, which is good for us, isn't it? So ABC is only for first class passengers. D and E decks are available for all classes, it seems. So D and E are available for all classes. And F and G decks are exclusively for second and third class passengers. Now, from going A to G, the distance to the staircase increases, which might be a factor for survival, isn't it? So the placement of a staircase inside a Titanic ship definitely bothers us, because that definitely affects the survival of a passenger when there's an accident, isn't it, guys? So that is why he had gathered all this information, and he had created a new column called deck from the first letter of the cabin column, right? And he had imputed M value, which means it's missing. Quickly he had done this. So from the cabin, he had got the the first letter, and he had imputed value M in all the missing values. And for all decks, he had grouped by with passenger class to get the count, and he dropped the other columns from the the data frame that he already have, and he tried to get these. I mean, this is a long thing, but let me show you the results, because we'll be running out of time. We are already 15 minutes away. So this is the passenger class distribution in decks, guys. So as you can see, ABC are with passenger class 1, and this is how they are distributed. 100% of ABC has first class passengers. Deck D, E, F were with second and third class passengers. He got the percentages of the occupation in this decks, and 100% of G deck was occupied by third class. Like that, he had transformed all the output into these insights, which are very important for us going forward. So passenger in the T deck is changed to A, because there's only one person on the board deck in T cabin, and he's a first class passenger. By looking at the data, you would understand, right? So we can move him to the A. I mean, we can impute replace the T with A, because there's no much data with respect to T. That was what we discussed, right? There's no much data. So going further, the author had got these values, and he tried to get the survival percentages in each deck. As you can see, survival percentage in the missing values says a lot here. So we are not ready to leave this feature as is, because the survival rate here is high and we need to know how do we balance this one. So every deck has different survival rates, and that information can't be discarded, isn't it? Because survival rate is a target column. Deck B, C, D, and E have the highest survival rates, and those decks which have and those decks are mostly occupied by the first class passengers. So M has the lowest survival rate. Oh, sorry, the green one is not survived, guys. So M has the lowest survival rate. So deck feature has high cardinality with right now with some of the values that are grouped based on the similarities. Let's understand those similarities. Let's understand those similarities. As you can see, A, B, and C are occupied by first class passengers. So decks are labeled. He changed them as A, B, C because the survival rates are also almost similar. So he had named ABC as A comma B comma C as ABC, and he had basically grouped by. M doesn't need to be grouped because we don't know what exactly they are, because they are of different values. They are missing values, and these are the counts, guys. Finally, so there are 180 people in ABC, 87 in DE, and FG. There are 26, but we are still yet to know how to fill this missing values. For now, we are dropping the cabin feature and seeing if there are any missing values. And as you can see, we have imputed successfully all the missing values in all the other columns. And target distribution of training set for class 1 is 38.38, and for class 0 is 61.62. So class 1 is nothing but survived, and class 0 is did not survive, right? So converting them into numbers, 342 of 891 passengers survived, and 549 of 891 passengers didn't survive as per the training data set. Fair enough. And this is how it was represented. And we are going ahead and understanding the correlations. Features that are highly correlated with each other and dependent to each other are, can be sorted using correlation coefficient. So where is the highest correlation is nothing but fare and P class, the passenger class. The other features are also highly correlated. So there are 9 correlations in training set and 6 correlations in test set, which are higher than 0.1. So you can see them here. As the author said, there's a high correlation between P class and fare, and P class and age, and all that stuff. So these are those features which have correlation greater than 0.1. He had summarized here, and he had seen them in this heat wave map. Now, we need to understand our continuous features. Continuous features are nothing but those are numericals which are not, which are continuous. They're not categorical, as in something like 0 and 1. They're not binary, basically. So this is kind of an EDA where he's trying to see the distribution, and you can see them. This is the thing that we do with all the, yes, good correlation should be near 1. Going ahead and looking at categorical features, guys. So I hope you know how do we do this analysis, bivariate analysis. We all know this, which is very basic. So the conclusion of all our exploratory data analysis is that most of the features are correlated to each other, and this relationship can be help to us to create a new features. We can transform the features. Feature transformation is something like binning, which I told you in the PPT. And we created a new feature called deck and dropped the feature called cabin, because cabin is specific, isn't it? B23, B21, and all that stuff. So we had transformed this cabin feature into deck and also tried to impute the missing values with M, right? So finally, for us, this is how we have formed the features which are transformed and engineered up till now. As you can see, deck was transformed a lot. Embarked, we imputed certain values. Fair, we imputed values. And age, we have imputed values. So going further, binning continuous features. So some of the features we can do binning, as I showed you in the PPT, where when you have a continuous feature, we can transform it to a kind of a categorical feature. So here the author is trying to transform this fair into kind of categories, and here he has fair versus passenger count, and then age also is being binned so as to convert them into a 10 quantile based bins for age. So they have made it into 10 quantiles rather than having it a large, um, a large range, something around, let's say, from 10-year-old to 65-year-old, which is a high range for you. Just look at the data distribution. You see, you look at the fair, it is distributed, it was not distributed evenly, so we try to bin and make it across 10 quantiles. So that is why we do binning, guys. So age is also binned like this, and then we do something called frequency encoding. What are we trying to do here is, as you can see, there are two columns with us. One is siblings and spouse, and the other one is parents and children. Now, what is the information that these two columns are trying to give is nothing but these two columns are trying to tell the family size. So the author had transformed these two columns into a new column called family size, and he did something called frequency encoding. So frequency is nothing but trying to understand how many occurrences are happening, and encoding is nothing but transforming it into like this: alone, small, medium, and large, the family size. So he had decided to have anyone who has come single on a ticket, they'll be alone. Who have come with 2 to 4 people on a ticket as small, who have come 5 to 6 on a ticket as medium, and anything greater than 7 is dubbed as large. So that is what he had done. So what all columns did we transform? We have transformed fair, we have transformed age, we have transformed the sibling, spouse, and parents and children columns. And you see, this is how it is reduced to. So why are we doing this? We are making things simpler for the model, so as to say, hey, this is the info. Please give me the prediction whether these kind of people can survive or not. That is what we are trying to do. And ticket, coming to ticket value, isn't it? They are very unique, isn't it? Because tickets have serial numbers, and that is what we have. So how is this feature different than family size? So many passengers traveled along with groups, and these groups consist of friends, nannies, and maids, etc. So they weren't counted as family, but they use the same ticket, isn't it? So why not we group these tickets by their prefixes? So as in, if prefixes are same, we can group them together based on the P class and or the embarked feature, and we can derive that from ticket feature, isn't it? So according to the graph, groups with 2, 3, 4 had the higher survival rate, as you can see. See, not survived and survived. The mustard color is the survived one. You see, small groups have survived a lot when compared to alone, medium, and large. The medium and large, the survival rate is very less. And when you compare with alone, let's not talk about it because there's a huge difference already. So yeah, that is enlarged here, guys. So this is how it is based on ticket frequency versus passenger count. Now, you can get to know whether a person is single or married from the title in the name. So the author is trying to derive that, and he had concluded that there are so many misters, and then followed by Miss, Mrs, or Miss, which means there are so many males. Females are little less, and kids and this is, VIPs kind of stuff. Now, finally, we are doing something called target encoding, which what we are trying to do is to extract the surname extract the surname from the name feature, and family feature can be created. So what they are doing using the surname, they are creating a family feature, and this name feature is being completely transformed into family, and also we can transform it using this title feature also. As I said, the name in our data set has three different parts: salutation, first name, and last name. So using that info, the author had converted into a family. And finally, he's trying to calculate something called family survival rate, wherein, whether certain families are survived or not, right? So the survival rate is calculated for families with more than one members in that list and sorted as per the survival rate feature. And he had an extra binary feature called family survival rate NA, which is created from the test set and which is unique. So this feature is also necessary because there's no way to calculate those families survival rate which does not have the surname, right? So here are the insights that he got. Let's go ahead to understand the insights. I'm not explaining the Python code, sorry guys, because we are running out of time. I just want you to understand the thought process first, and since it's publicly available, I can share you the link little later at the end, and you can go through the code once again. Here I am trying to convey you the thought process that is necessary for you to understand how to attack a problem. So feature transformation. As I said, we have taken up certain features so as to transform them, which are nothing but these are the non-numeric features, the categorical features. We'll be doing the label encoding so as to, if it is male and female, we can make it binary 0 and 1, and as such. And one hot encoding the categorical features, we can also do one hot encoding. So what are these? You can Google and find out what is the difference between label encoding and one hot encoding. So passenger class, the gender, deck, embarked, title, and family size group, which were transformed previously here, are again being converted into numericals, guys. I hope you remember we have small group, large group, medium group, alone group kind of stuff, right? All of them are transformed into numericals. And finally, here you can see what are all the transformations, feature engineering that we have done. Here it is summarized in section 2.6, where age and fair features are binned. And this binning helped us to treat the outliers. Somebody asked me previously how to treat outliers. Binning is the binning is the way to do it. So that's how we have treated the outliers in age and fair. And family size is created using the two columns that we have: parents and children, and siblings and spouse. And ticket frequency is created because the ticket column has unique values. So we don't want those unique values, which doesn't make sense. When there's a ticket number, something called 132T56MNX, what do you make? What does the model think about it? It can't think, right? So that's why we are trying to transform that ticket feature into a ticket survival rate based on the count of it, right? So they have transformed it into ticket frequency. Likewise, name feature, in which we have first name, last name, title, and all that stuff. We have created new features called title and is married, to understand whether the person is married or single. And finally, we also have family survival rates, that are features that are created using target encoding from the surnames of the passengers. And using all of these features, we have formed a new data frame which has all numbers, as you can see: age, dex 1, 2, 3, 4, where they have embarked, family size, whether the person is married or not, fare, passenger class 1, 2, 3, gender, male or female, and survival rate, and ticket frequency, and the title, whether they are belonging to whether they are belonging to Mr., Mrs., as in all that. Yes, feature engineering is definitely not a cakewalk. This much we need to think through, and this much we need to do so as to get very good accuracy. And that's why I did not discuss about the code. I am just talking about the results that the author had achieved and the thought process. So, how do you achieve such kind of a thought process? Can you do it overnight? Definitely not, guys. You will have to practice with different data sets, go through different Kaggle notebooks, and understand how they have attacked the problem. As I said, with a analogy, there's a crime that had happened, and we need to investigate it. And how do you do it? By using every nook and corner of the crime scene, which is the data for us. And we need to catch the criminal, which is nothing but the insights, the right insights. Always remember, the good accuracy does not imply good insight unless and until you do such feature engineering techniques and you do understand the domain knowledge. I hope you guys are understanding the value of feature engineering and domain knowledge with this example. Let me quickly show you how further the model was applied. So the author had this much of numerical data. He had prepared all this. As you can see, the whole data set is completely transformed. And now the usual stuff, guys, we all know, right, how to do this stuff. So he had taken X train and Y train. Y train is nothing but the target. X train is all the other features that we have. X test is nothing but the all features other than the target column, because we need to test the model with this. And here the target is trying to apply random forest, and he's trying to tell us that he had tried different models and this has given him the highest accuracy. And this is another area for you to look into, because he had done this in a very nice way. So random forest classifier with Genie, and he had given all these aspects so as to get the predictions done. Uma Mahesh, we can do XGBoost also. We can apply any model. It doesn't matter to us. It depends on the size, not just size of the data. It also depends on the kind of data that we have. So here the author had applied random forest because we all know how random forest works. So it is generally, when I am trying a model, I would first try on random forest just to see how well it performs. So these are the predictions, and this is why you can use feature. You can get the feature importance on how the random forest has considered the features. So as you can see, the random forest classifier had used ticket frequency as its go-to feature to depend upon. And it had considered deck 4, it has considered the family size and all of that. And finally, here the evaluation is happening, guys. Region and region over curve is up, as you can see, it is used to evaluate this model. And further, it is finally submitted saying that passenger ID versus the survived. So the predictions are served like this. So you guys are discussing about model selection. That is a whole of a different topic, guys. But let's just focus ourselves onto feature engineering, extraction, selection, and transformation, which is the major part. As you can see, this is a very small data set, and it is a normal data set. Any data scientist would be first trying to work on a Titanic data set. I hope you all who have tried data science must have started with Titanic data set. But did you all even think like you can do like this? What do you guys think? Please ask questions with respect to feature engineering and the thought process only, guys. Please understand, we are trying to understand the thought process. If you have any specific questions on thought process, let me know. All the other questions that you guys are asking, those are readily available. You can easily Google and get to know more information on that. And it will be it will take a lot of time for me to sit and answer such questions. I hope you're understanding my intention, guys. Yes, see, what all that we have seen today might be too much for you to understand. Just keep this understanding aspect aside. Just look at this session about how do you think about it. So I want you to understand that do not jump into model immediately. When a data is given, first understand the data and then go ahead and do feature selection, feature engineering, and feature transformation. That's what is the conclusion that I wanted to give you. And this can be done in GCP or AWS or Azure by using their services. See, in Kaggle, it uses also cloud services. And so in GCP, they have certain architecture. So using their architectures, you need to do. Again, that is a cloud knowledge, which is separately, which is a whole lot of a different topic. To practice such thinking, going through Kaggle notebooks will help, but where else the thinking is also documented. That's the problem, right, Sai Deepa? The whole problem is we don't have anywhere documented on. Oh, I'm sorry, I'm giving the Kaggle link, guys. Yeah. So we don't have anywhere that this is documented. You would understand and formulate your thought process only by practicing. As a data scientist, we need to play with different data sets in such a way that we can do it. Sorry, someone is saying something. Feature selection is like a forensic scientist will do. Yes, thank you. Yeah. Yeah, I think this is a right way to say. When we give garbage to the model, it gives us the garbage. It does not give us proper predictions. And that is why we need to get the diamonds from the coal, isn't it? So diamonds are always hidden in the coal. You need to work out a lot to bring out that diamond. Likewise, our insights are hidden in the dirty data sets. We need to do data engineering, get the data, understand the data using exploratory data analysis, then go ahead and do the feature engineering so as to send it to the model. Oh, I'm sorry, Uma Mahesh, for time series problem. See, whichever the problem is, this is the first step. You can't proceed without doing exploratory data analysis and doing certain feature engineering aspects. But for time series, based on the objective, the way you do it changes. That's it. Vivek, feature importance is calculated using a Python code. I mean, that's a different topic. You can use this notebook code to play around. Yeah, sklearn is used in real time too. Why not? For feature importance, the model considers all the features that we are giving, and it tries to give importance based on how it understands the input that we have given. How can we improve our thought process? As I had been saying, we first step is to go through different data sets and different Kaggle notebooks, and you would be understanding it. I'm sending the Kaggle URL to everyone. How to participate in Kaggle competitions? There's a lot of documented blogs on it. You guys can follow. Any other suggested data sets? I would say start with Titanic. As you can see, this is a very basic data set, guys. It has only 800 rows of data. So did I answer all questions?
Hi, Anadip. I hope you have answered all the questions.
Yeah.
And guys, I would like to request the attendees to please fill in the poll about feedback. as it helps us to conduct more sessions like this. And guys, Anudip has answered almost all of your questions. And thank you, Anudip. On behalf of Analytics Vidhya, I would like to thank you for your time and for delivering such a wonderful session. I am sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future. And guys, if you have any doubts, please feel free to connect with Anudip. You can find his LinkedIn profile in the chat section.
Yeah, thank you, Dheeraj, and thank you everyone for attending the session. I know you might be having all sorts of questions related to data science. I'm sorry I can't clarify right now, but you can connect with me and we can talk it up. And you can attend many analytics Vidya sessions by other professionals also. I hope you all, achieve heights, and all the best for everyone in your careers. Thank you so much for attending, and thank you for taking time to rate me on the feedback poll. Thank you, Dheeraj, once again. Thanks for having
Yeah,
me. Yeah.
sure, no problem. And guys, if you wish to conduct a webinar, or if you are facing any difficulty in registering, please do connect with us at editor@analyticsvidya.com. Let me share this email ID with you. And guys, the recording of the session will be available in a few days on our YouTube channel. Thank you guys. We will be back with another session after DataHour on tomorrow, that is 20th August. And we have many more upcoming sessions. Register if you are interested. The links are in the chat section. I hope everyone can see the upcoming sessions links. Yes. Once again, thank you, Anudip.
Thank you, Dheeraj. Bye.
Yeah. Bye bye. Till then, bye bye. Keep learning, guys.